All right, so we're going to be looking at today angles that are not inside a right triangle or any kind of triangle. We will use a triangle to sort of explain where the trig functions come from, and then we're going to be looking at things completely apart from the triangle. And this is going to lead up to the idea of the trig ratios being functions, something that we could graph. So we're starting off with an x and y axis here. So I'm going to mark this x and y axis, just a normal graph that we would graph points on. And we're going to put a point over here in the second quadrant. And I'm going to call it xy, just a general point. We don't know what the coordinates are. Don't need to worry about the fact if it's positive, negative, or anything for what I'm doing initially. We're going to make an angle. We have graphed angles in the coordinate plane, plotted angles. We're going to do an angle in standard position. So the initial side's over here on the positive x-axis. And the terminal side's going to go through a random point that we came up with, this xy. There is a way to have trig ratios for this angle that goes from here to here, theta, using this point. And this is kind of a cool idea. Where it comes from, we could draw, I'm going to use a red pen just to illustrate. We could draw a line from here down to the x-axis to make a right triangle. And then what those coordinates were would give us sides of the triangle. And we would consider this angle over here a reference angle that kind of goes with it. But if so we're going to get it's going to get a little confusing. But basically, this hypotenuse right here, we're going to call r, and that's going to stand for radius of a circle that we're going to talk about in the next lesson. And we can find that length using Pythagorean theorem. So it's going to be the square root of the x-coordinate squared plus the y-coordinate squared. If you use the distance formula, Pythagorean theorem, either one, that distance comes from that. And that's using this point xy. All right? So if you are given a point xy, with or without a graph, we can come up with all of these. So sine of theta is y over r, your y-coordinate over this distance that we calculate. Cosine is x over r. Tangent is y over x. And then these are just going to be the reciprocals. So cosecant's r over y, secant is r over x, and cotangent is x over y. So basically, it's a shortcut kind of sort of for finding trig ratios for some angle that's graphed that's not necessarily part of a triangle, but it kind of goes along with the triangle. I probably should have drawn this angle in the first quadrant to really explain it. But these are the ratios we're going to use. So over here, I'm going to show you how this works. It says evaluate the 6 trigonometric functions if the point negative 4, 3 lies in the terminal side of angle theta. We don't have to draw the angle or do anything else. We do have to calculate r. So r is going to be the square root of negative 4 squared plus 3 squared. Those are the numbers out of the point. And this is going to give us the distance from the origin to the point negative 4, 3, which is the hypotenuse of that theoretical triangle we talked about. So negative 4 times negative 4 is 16. 3 times 3 is 9. These numbers should both come out positive no matter what, because you're squaring them. And we get the square root of 25, which happens to just be 5, because 5 times 5 is 25. And then the negative 4 is your x, 3 is the y, and we just have to use these ratios from over here to set everything up. So sine is always y over r. So the y-coordinate's 3. R we just found is 5, so sine is 3/5. Not too bad, right? Cosine is x over r. So x is negative 4, so negative 4/5. Tangent is y over x, so 3 over negative 4. A lot of times they're going to actually just rewrite that negative 3/4. If there's just one negative in there, they just make the whole fraction negative. And then over here, we're just going to flip them over. So 5/3 negative 5/4, and negative 4/3. And you do not change any of this to mixed numbers. We just leave them improper. If the fractions simplified, if I could actually divide something out, we would do that. Okay, so this example was pretty straightforward because this came out a whole number. Sometimes we will get some radicals. So it's okay. We've been doing radicals for a while. But some of these will be a tiny bit more complicated because of dealing with the radicals. So if we go on to the next slide. It says evaluate the 6 trigonometric functions if the point 1, negative 3 lies on the terminal side of angle theta. So this is my x, this is my y, and then we have to calculate r. R is going to be the square root of 1 squared plus negative 3 squared. And you don't want to actually take the square root on your calculator. You want to figure out what this number is. So 1 times 1 is 1. Negative 3 times negative 3 is 9. So we get the square root of 10. You could check to see if this simplifies, but 10 is just 2 times 5. There's nothing that you can take out or reduce. So we're just going to use that for r. So when we do sine, if we look up here, sine is y over r. So y is negative 3 and r is the square root of 10. It's not considered okay to leave the square root of 10 in the denominator. Do you remember how to get it out? Multiply by radical 10. Good. So then you get negative 3 radical 10. And then this is the square root of 10 squared. It just becomes 10. And that's why they do it, is to get that out of the denominator. Okay, but if I come over here to do cosecant, I don't want to flip this back over because that's going to put that square root of 10 back in the denominator. Go back to what you originally had and do square root of 10 over negative 3. Or you can do negative square root of 10 over 3. Either way, this is how you're normally going to see that. All right, cosine is x over r, so it's going to be 1 over the square root of 10. Similar situation. You got to get the square root out of the denominator, so multiply by the square root of 10. You get the square root of 10 over 10. When I do secant, what am I going to do? Square root of 10 over 1, which is just the square root of 10. So go back to what you had in the beginning, or go back to what we wrote here and just do r over x. I never liked memorizing 6 things. I memorized these 3 and just remembered that these were reciprocals. For me, in my brain, that was easier. I memorized as little as possible and just worked things out that way. Okay, so tangent is y over x. So that's just negative 3 over 1, which reduces to negative 3, and that's it. So cotangent, we flip that over, is just negative 1/3. So not too bad. All right. Moving into the next box. It's the same directions. They're giving us the point negative 7,4 lies on the terminal side of an angle theta. This is x. That's y. We calculate r. Those are basically the first 3 things you want to do. So figure out what that is, and find this. So this r is going to be the square root of negative 7 squared plus negative 4 squared. This is going to give me positive 49 and positive 16, which is the square root of 65. 65, I think, is 13 times 5, so it does not reduce. So we're just going to leave it the square root of 65. Just be aware occasionally you're going to have one of these that you need to use the birthday cake method and simplify. It just makes everything over here come out the same as the answer key when you do. Okay, so for sine, we need y over r. So negative 4 over the square root of 65. Darn square roots in the denominator again. So multiply by the square root of 65 or the square root of 65. Or some of you may have done this enough that you can just go, okay, it's going to be negative 4 square root of 65 over 65 and call it good. And you should always check that the 4 in the 65 don't simplify, that nothing's going to be where you could reduce it. Cosecant, you flip over what you had originally, so it'll be negative square root of 65 over 4. All right, tell me how to set up cosine.
It's going to be negative 7 over angle 65.
Good.
And you're going to have 2 times by radical 65.
Good.
And
Negative.
reduce, so you're good.
Yep, negative 7 square root of 65 over 65, and nothing there reduces, so we're good. For secant, I just go and flip over the original, so it'll be negative square root of 65 over 7. And then on tangent, it's y over x. I'm going to have negative 4 over negative 7. That doesn't reduce, but it's a negative divided by a negative. And when that happens, they cancel, and your answer is positive 4/7. So you do need to get rid of that negative situation going on there. All right, cotangent is the reciprocal, so 7/4. So that basically gives you an idea of what these are going to look like. Then I'm going to give you a sample of the sorts of things that happen if your point happens to lie on the x-axis or the y-axis. Because some funny things happen when you have zeros. In my original set of notes, we did a lot of these. I am only going to do one set, and then we'll talk about it. So we're going to do the 6 trig functions if it's 3, 0. So if you think about 3, 0, I'm actually going to draw a little picture out here. Be like right here if you were graphing that. It's on the x-axis. And that angle, if your initial side and your terminal side are both over there, would be 0 degrees. So we're actually figuring out how to do sine, cosine, tangent, etc. with 0 degrees, which is not an angle that would ever be in a triangle. We need to start thinking outside of triangles and start thinking about, we want to make this into a function we can graph with x and y, and what those relationships are, and how do we deal with those zeros. So I'm going to figure out what r is first. So r is the square root of 3 squared plus 0 squared, so that shouldn't be too bad. I end up with the square root of 9, because that's just 0, which is 3. So for sine, this is x is 3 and y is 0. So for sine, we need y over r, so that's 0 over 3. So if I take 0, nothing, and divide it among 3 friends, we all get nothing. So you go ahead and reduce that down to 0. Let's think about the reciprocal, though. For cosecant, you're going to do r over y. So that would be 3 divided by 0. You can't divide by 0. Mathematically, things blow up. Your calculator will say you've got a domain error, crazy things. We call this undefined. So there's not an answer there. And when we're graphing things, cosecant has some places where there are no points. That happens to be one of those places. Will be at 0 degrees. Okay, when we do cosine, cosine is x over r. So x is 3, r is 3. 3 over 3 is 1. Secant, if I flip over the fraction, I still have 3 over 3, and I get 1. Tangent is y over x, so I get 0 over 3 again. It's a different 3, but it's the same answer. I get 0. And then here I'd have 3 over 0, and it would be undefined. Now what's cool about thinking about this in terms of a point on an angle is it wouldn't have to be 3, 0. It could be 5, 0. It could be 1, 0. Any point that lies along here is going to be on an angle of 0 degrees. Your sine, cosine, tangent, cosecant, secant, cotangent is always going to be 0. In Knowledge Bowl, you may have heard questions like, what is the sine of 0 degrees? And thought, how the heck can you do that? That's not a triangle. Well, it's 0. Or they might ask you, what is the cosine of 0 degrees? And it's 1. And you're thinking, how can you get 1 out of 0? This is how, by thinking about it on a graph. And we could do the same situation with points on the y-axis and this x-axis and down here, and they come out differently. We're going to attack that a little later on. I just wanted to introduce this idea of we're starting to think of the angles as an input for a function, an x, to get a y, which is different from this x and y, and there's many layers, but it's where we're headed. All right, so you'll also notice something strange. that we have some negatives happening. That didn't happen when we were doing triangles either. You didn't get negatives. But that can happen when we have our graph, because in some quadrants, some of our coordinates are negatives. So there's a way to remember that'll help us out later where things are positive and negative. All of your trig functions, sine, cosine, tangent, whatever, are all positive over here. So all positive, I'm going to write over here. And that's because your x and your y are both positives, and then your r always comes out positive. So no matter what, sine, cosine, tangent, all of those fractions are going to come out positive. Now when you get to the second quadrant, you have negative, positive for your points. You go left and then up. And so that's going to make anything that uses x negative. So if you look back to the beginning, which functions use x? Tangent, secant, cotangent. So those are all have x in them. They're all going to have a negative. Sine and cosine will still be positive. Everything else is negative. The easiest way to remember this is to look at which ones are going to come out positive, because there's not as many. So sine and cosecant are positive. Everything else is negative. And don't worry, I have like a mnemonic device for this. And this is going to be one of those tools that we'll talk about a little bit with SATs. There's not a lot of weird, obscure trig on there, but they will occasionally pick out some things to be on that last page of problems. You know what I'm talking about. The ones you're like, what the heck is this?
You mean all the math.
Yeah. I'm going to try to give you guys some tips and some things, and also some knowledgeable tips too as we move through this unit. Okay, so when we look at 3, your points are all, you've got negative for x and y. So anything that uses an x or a y is going to come out negative, but anything like tangent that uses x and y is going to, like we had up here, is going to cancel out and be positive. So what will happen is you'll have tangent and cotangent are the only two that are positive. All of the others should be negative. And then in the fourth quadrant, your points are positive, negative. That's just how the x and y coordinates work. And so anything that uses y is going to be negative, which is sine, cosecant, tangent, cotangent. So the ones that stay positive would be cosine and secant are positive. Okay, so there's a way to remember this. It's a little obscure. When I learned this, I only learned sine, cosine, and tangent, what the ratios were and what their signs were. Because from there, I could figure everything else out. I didn't have to memorize a whole lot for tests or ACTs or whatever. I didn't take SATs. We did ACTs in Kansas, but it's just whatever. Okay, so I'm not thinking about the cosecant, cotangent, secants. I'm just thinking, so this is how it works. You start in the first quadrant and go around. It's all students take classes. It's dumb. I've also seen all students take calculus, but that's not true. I didn't like that one. So all students take classes. So all of them are positive up here. S is for sine. Sine and its reciprocal would be positive. Take T for tangent. Tangent and its reciprocal will be positive. And then classes is C for cosine, and its reciprocal would be positive. Okay, it's a lot to remember. And we're going to use this to answer the really obscure question on the next page. You need that?
That's negative and negative.
So all students take classes. All of them are positive. Sine's positive. Tangent's positive. Cosine's positive. And then you'd have to know which ones are inverses of each other. So okay, you guys ready? So if we flip to the next page, keep this open so you can see what we just did. It says name the quadrant in which the angle lies. And they're going to give us some really cryptic clues. They're saying sine of theta is less than 0. Basically what they're saying is sine is negative. cosine theta is less than 0, that means cosine is negative. So you need to figure out where sine and cosine are both negative, and that would be the one where they're not listed, either one is positive. So if you go back over here, if you go down to the third quadrant, tangent and cotangent are positive, but sine and cosine would be negative down here, so that's the third quadrant. I know. I know. So on the next one, sine is greater than 0, so sine's positive, but tangent's negative. So you want to find some place where sine's positive and tangent's not. So take a guess, look at your little chart. 2 does look like that would work. So quadrant 2. Because sine is positive, if I go back over here, sine's listed as positive, but tangent's not. Tangent is only positive down here. And if sine and tangent were positive, the only place that can happen is over here where they're all positive. Okay? I know. It's just kind of a way to think about things. All right. So, practice problem. We're just going to write a quick one. I'm not going to make you do all 6. Not going to make you do all 6. So I'm going to give you the point negative 2, 21 is on the terminal side of an angle. Okay? And then I'm just going to have you find sine, cosine, and tangent for that angle.